Hi, today we are going to look at how to solve equations using algebra tiles. So oftentimes we're given an equation and we're told to do the inverse operation, don't really understand why we're doing that. So we're going to look at what to do with algebra tiles and solving one-step equation or two-step equations. So first off, we look at this image and we see that this right here, that's an algebra tile, that's our variable, and we consider that x. So if you look at our picture over here, we see that x is divided into 1, 2, 3, 4 parts. So this is really saying x divided by 4, which we could also write as 1/4 x. And then we have 1, 2, 3, 4, 5, 6, 7, and we see that yellow is positive, so plus 7, and that's equal to 9. So we want to look at what we will do with our algebra tiles. So when we are solving, we know that in order to figure out x, we have all of these individuals first, and we want to figure out how to get rid of them. Well, we learned about zero pairs in Math 7, and so we know if we make zero pairs here, that they will cancel out. So we notice that we will have 7 zero pairs to cancel out all of the positives on this side. Well, we know with an equation, it needs to stay balanced, so we also have to add in 7 zero pairs to the other side. So that's 3, 4, 5, 6, 7. So, oh no. When we line them up, we notice we're left with 2. So now let's think about what we're left with. So what we did was we took away 7. We made those 7 zero pairs, which canceled this 7 out and left us with 2. So we're left with x divided by 4 is equal to 2. So what this expression is telling us is that x divided into 4 parts is equal to 2. So the same thing as 1/4 of x equals 2. So right now, not all of x equals 2, but just one of these is equal to 2. So if we know if one of those is equal to 2, then each one has to equal 2. So this one would equal 2, this one would equal 2, and this one would equal 2. So in all, you have 1, 2, 3, 4, 5, 6, 7, 8. So you have x equals 8. Well, really, what we did, and what people always say, oh, we have to multiply by the 4 to get rid of it. Well, we're multiplying by that 4 because we're really saying each section needs 2, so we are doing repeated addition, or we can multiply. So we get in the end that all of x equals 8. All right, let's try another problem. We have this value here, and again, we are trying to solve for x. So we notice we have 3 x's, and then we have the red, so that's 1, 2, 3, 4. We're taking away 4, and that's equal to -16. So again, we want to figure out how to get rid of first those -4. Well, we know if we add in our zero pairs, those will cancel out. So if we added in 4 over here, we'll have to also add in our 4 zero pairs on, the other side. So now we just eliminated that minus 4 by adding in our 0 pairs. And we have 3x, and if you see now, we're left with only 12, but because they're red, it's going to be negative 12. Okay, so now we're left with 3x's equals negative 12. Well, we only want to know what 1x is equal to. Since these are all of the same variable, we know they have to equal the same thing. So if we know that 1x is equal to 3x is equal to 12, we know that 1x has to equal negative 4. The second x also equals negative 4, and the third x also equals negative 4. So if we just want one of these x's, we know it's negative 4. So what we did is we had to divide what was left over into 3 parts so that we could figure out what x was equal to, and we get that x is equal to negative 4. I hope this helped you understand the reason why we are doing the inverse operations for equations, and enjoy using your algebra tiles.